in the right spot. This is these innovative tricks for project requirements will change your life. Everyone's in the right spot? Are you ready to have your life change? All right.
Yeah.
So, in case you don't know who I am, my name is Becky Linton. I'm a senior systems engineer for Conrad Technologies. I'm also a LabVIEW champion and a certified LabVIEW architect. My co-speakers over here, we have Chris Beuschel, one of my co-workers. He's a certified LabVIEW architect, or test stand architect, and he's lapsed on his LabVIEW certification, so get on with that. And then we have Q here, who's also a LabVIEW champion and architect as well. And so, we're all part of what we're calling the CPAD track. And so CPAD, if you haven't heard of it before, is Software Engineering, Processes, Architectures, and Design. This track was started 4 years ago by the LabVIEW champions, because how many of you have been to NIWeek like a long time ago? How many like NIWeeks? Quite a few? Like 5, 6? Does anyone remember the days when all the presentations were just marketing? When it was like, all right, you look at it and you're like, oh, new features, great. Oh, new products, great. But you didn't really get any great technical content. And so the champions set out to change that, because even though you might not be a certified LabVIEW architect, we feel that you should still be privy to the information that we feel is important to you guys, right? Stuff you should learn so you can become an architect at some point. And so the idea was, we had one room, we called it the Advanced Users track. From there we set out, and it's grown significantly such that we have, I think it's 60-some sessions this year across all the rooms. So if you go back to the main floor, I don't think we have any up here right now, there's a single sheet of paper when you check in, and it's got all of the CPAD sessions. Now, this year we're doing something a little bit different in this room. We're actually doing a mini track. And so we're really looking for feedback. We didn't pick out our project till a little bit later, but I want to know what you guys think of the idea. The whole idea is, in one room you could sit here all week and follow a project from start to finish. Hence why we're starting with requirements. So the idea is we get requirements, we figure out design. How do we choose a framework for our customer and our DUT? And then how do we actually implement it? How do we go about unit testing it? How do we deploy? Things like that. And so we'll see how it works out this year. We didn't give the information to the speakers and ask them to try to incorporate at least 10 minutes of their presentation into it. So again, let us know what you think of the idea in general and what you think of our implementation this year and how we can make it better next year. So this year, here's our DUT, if I can figure out the clicker. Can you hit it too? It's not liking me. I went too far. All right. So this is actually used by National Instruments for some internal training. They have a fake customer called Becky, and they have a DUT which has a linear array of MEMS digital microphones. The DUT supports 6 equally spaced microphone modules, and just so you guys know, we actually have the DUT, and I made this board up, and it's a custom PCB, and it connects to a MyRio. So they use this for internal training, like here's some requirements, here's a test, here's what I want to do, and we actually, you can see my voice speaking here, the microphones are picking it up. So I know for a fact the people covering Unit Framework as part of this track, Unit tested some of these software that NI has as their solution for the problem. So it's kind of interesting. And you're welcome throughout the week to come look at this and see what's going on. So let's take a look. This is the documentation that NI has as part of it. So we've got a CSV file example, a JPEG of it, some test limits, the format specification, and all requirements. I don't need to do anything. The customer gave me requirements, right? I mean, the customer doesn't want to pay for me to write requirements. They gave them to me. So let's actually take a look at the requirements. Best being system and test system specifications. It's got some good sections there. Introductions, provides the information needed to understand the DUT. Here's some information about the DUT. Okay, I don't really see any requirements yet. Just some information that's useful. There's the DUT. Oh, here's some more how I can find it. Here's how the data clock works. Still not really any requirements, just good information. Oh, here we go. There's a temperature transducer. Here's a data sheet. Oh, it's controlled externally using SPI. That's good. Here's some hardware maps. Oh, here's what they want. Okay, the measurement setup should look something like this. There's the whole requirements right there. Generating acoustic step sign signal, full range, couple things there. Okay, that looks like valid requirements, don't they? Does anyone see any problems? Are these really requirements? How would I trace these requirements? There's no numbering scheme. There's no way to track them. So even though this is a requirements document, it's not really the best way. And so why do we even need requirements? I think we're turning over to Chris. Is this you?
Yes.
You took out my slide. I had a big slide that said specifications are not requirements.
I wanted to talk about why requirements themselves are important.
I think there's a decent chance that everybody in this room has interacted with requirements, regardless of whether or not you've written them yourself, if you've taken them from a customer, or just been downstream of having to implement these. The customer that we're talking about here doesn't always have to be somebody outside your organization. It could be your boss, it could be the guy next to you. But at the end of the day, what these mean is somebody's giving you something to do, and you have to set a bunch of rules for you or your team so you can make sense of the project and work effectively to do that. Requirements give us an opportunity to baseline our project, to make these set of rules, and to get familiar with what the project is trying to accomplish. In doing so, you understand what your deliverables need to be as part of that project, and it gives you an opportunity to work with that customer to set up what your boundaries are, what your scope of delivery is, and then prevent that scope from changing. So we use these as a tool to make sure we know what we're doing, and that if that has to change, that we can kind of control what that change is. And there's a quote that we actually throw around related to requirements. It's not enough to do your best. You must know what to do and then do your best. So doing your best, going 110% on something that's not well defined, isn't going to be a very useful effort. You're going to waste your time doing things that you don't need to do or are too expensive. And requirements are a useful tool to make sure you don't end up in that situation. This is Becky's slide that I stole. So the specifications that we just saw aren't the same as requirements. There were some things in there that sort of looked like requirements, but ended up being a superset of things the customer wanted about the product, vague notions about how the product should work or how our test system should work. They didn't give us a real clear plan or set of rules on how to implement that. So our specification ends up including extra things like design constraints, which can be, I'd like to use a certain type of instrument, or I need to interface with this specific chip. That's not necessarily the role of requirements. We want to capture function and not design. So by looking at specifications, we can get an idea of what requirements need to be, but we also need to take the time, the opportunity to go through and decide functionally what are we trying to accomplish here in the scope of our own system, and leave out all the rest so that the work that we do is focused just on what we're responsible for and not the bigger system scope. Requirements should answer what is it doing and not how is it doing. That's that separation between design and function. So we know what the DUT is capable of and how we need to test it, but not necessarily saying we're going to go use this instrument or this process necessarily in the requirements. An important part of this opportunity to go through and get familiar with requirements at the beginning of the project is to also think about how are you going to prove that you've met these goals when you get to the end of the project. That's the verification stage. And so what we see here is a standard B model. Right up at front, we've got the initial planning stage, we're looking at requirements. We're building this list of rules, of goals that our project, our solution needs to meet. And at some point, we probably need to prove that we've actually done that. That's the role of verification. And by working through the requirements early and also thinking at the same time, how do we verify these? We have already set ourselves up for success down the road to say, we plan to do it this way, the system has to work this way, and this is how we're going to prove that we accomplished that goal. So the early effort saves us effort down the road, and we'll actually talk about verification in a little more detail after this. So you've got the specification, you've got a pile of documents from your customer, an example report, and some pretty pictures, whatever they want. But how do we take that and turn it into requirements that are useful, that we can track, and that we can prove we've met? This list here is taken from IEEE 29148, 2018 rev. Has anybody seen this list of parameters before? Excellent. So these are a list of 8 different parameters that feed into what a requirement should be. So you can see there's correct, unambiguous, complete, consistent, ranked, verifiable, modifiable, and traceable. So at the outset, that can kind of seem like a lot to go into just one statement. Based on the scope of your project, the regulation of the industry you're working in, you don't necessarily have to focus on nailing all of these, but these are great guidelines to know whether or not you started off in a direction of quality. Because when you write requirements, these are the rules that you have to follow when you're working. These are what you have to verify at the end of the project. You want these to be well written, to be complete, consistent, unambiguous. And the IEEE spec here is actually based on the concept of requirements engineering. And I think probably most people, even interacting with requirements on a regular basis, don't consider that a discipline of engineering by itself. But if you've ever worked on a big enough project, you know when your requirements document is 40, 60, 80 pages long, because the system is huge, there is an art form and absolutely a discipline that goes into deciding how do I build these requirements so the system can be successful. And this is traditionally a systems engineering type aspect. Most people, most engineers that run into projects aren't system trained. So you don't have the background in this specification. But requirements are a very easy, approachable systems discipline to give you a tool to make your project less painful in the long run. When we're writing requirements, terminology is incredibly important. The way that we write these has a direct correlation to how we're communicating to our customer, what we're trying to accomplish, and then later how we're going to be able to verify that. If you write an ambiguous requirement, you can end up in a situation where you provide a requirement that can't be proven. Or worse, you write a requirement with terminology that you understand, but your customer doesn't. So when your customer signs off on your requirements document, you're agreeing on two different things. So what you see here are 4 standard verbs that are commonly associated with requirements. And they have different levels of meaning associated with each word. So we have shall at the top. This is a mandate. This is a requirement that must happen. The system shall do this or have this behavior. Moving down to should, this is more of a suggestion. It is not a mandate. You don't have to do it, but it's a recommendation based on the context of the requirements around it or the larger system scope. The system should. Will is more leaning in the direction of larger context or purpose. We don't need the system to do it. It's not even necessarily a process that we're recommending, but it provides a reason for the system to act a certain way. And then finally, may is where we get to just pure suggestion. The system may operate on such and such. The example that actually makes these stick well for me is you're in a receiving warehouse. So received shipments shall be inspected before entering a warehouse. That has to happen. You have to go through every shipment, maybe make sure there's no damage before it can come in the building and be part of inventory. The incoming shipment should be inspected before entering the building. Okay, it's a good practice, but not necessarily required. You may get some fall through as a result because it's not a mandate. The incoming shipments will be, okay, so we're going to do it, we're not telling you really how or who's responsible, and that makes it what is an unverifiable requirement. It gives you a suggestion. There's no way for you to prove that that's happening. It gives you an idea that it should happen. And of course, the incoming shipment may be inspected, just kind of says that someone should do it. And then leaves that kind of open-ended for the rest of the document to flesh out. So I'd like to go through a couple examples and see if we can decide, based on the terminology and specifically the terminology, are these requirements well written? Are they communicating what they should? Or are there gaps that we want to work out? So this first one is, the test software shall not crash within 1 year of use. Is this a good requirement or a bad requirement? Hopeful. All right, yeah, absolutely. We would consider this a bad requirement. It's a good intention. We don't want software that crashes, and we want it to be stable for a long period of time. But if you have a requirement that says the test software shall not crash, that means you have to run it for that time period in order to know that it hasn't crashed. And if you ever make a change, when that interval changes, you now have a test plan that lasts at least a year. So this requirement, while good intention, is not easily verified. You could, but it comes at tremendous cost. And that's a great point. What does crash mean? So it's ambiguous in the terminology. What actually qualifies? Does the software stop? Do we lose data? There's just not enough information to treat this as a proper requirement. The next one. Ooh, all right, well, we skipped the transition. The system shall read the UUT serial number from a barcode. This is better. This is more contained in scope. We're dictating that the software will process a serial number from a barcode, We don't get concerned about what barcode scanner is being used. We don't care about necessarily the format of the barcode or where the barcode is coming from at all. This just gives you an opportunity to say, yes, I have extracted a serial number from a barcode, and you can work from there to provide the larger solution.
Excuse me.
Yes.
The previous requirement that you had up there, what exactly makes it bad? Is it bad because it's hard to do, or just bad because it's poorly worded?
It's actually both. So it's difficult to prove that anything works for a year consistently, because in order to do that, you have to see that it works for a year. Most of the time, you can't really do accelerated life cycle testing and say it definitely works for a
So
year.
what if you tested it on multiple systems? Wouldn't that combined time be worth it?
I mean, there are opportunities to do parallel testing where you could reduce the time frame like that, but at the end, you are introducing another variable that may not actually match the use case of the product. So you've introduced a deviation between what the intention of your requirement is and actually how you're trying to verify it. And then the point that Becky made about the ambiguity of crash, that can mean different things for different audiences. Your customer, who maybe is not familiar with programming, would think crashing is maybe it stops responding for 5 or 10 seconds. Whereas programmers, we would consider a crash outright, the process dies, we lose all our data. So somewhere in between, there may be something that happens that we can't actually assess clearly if that was a crash or not. Does that answer your question?
Yeah.
Another aspect, oh yeah, absolutely.
Previous requirement, isn't barcode a little bit ambiguous because now there's a barcode, barcode?
There absolutely is. That's because it's usually driven by a product.
Can you repeat the question?
Sorry?
Repeat the question.
Oh, yeah, of course. So the question was, is barcode an ambiguous term to use in this requirement? And depending on the context, that's a valid case to make because there are a lot of different varieties of barcodes that could be used. By using the term barcode, you actually don't get stuck in what type of barcode. Sometimes you do want to avoid adding certain details because if they change, then you have to revise your requirements and then change your verification plan. So this is a pretty safe requirement in that regard. You could then have a separate requirement that says the software shall recognize barcodes of the following formats. And then that way you have your baseline requirement that meets the real need of the software and a secondary requirement that dictates the more specifics of how you're interacting with your product or your factory system or what have you. All right? Second aspect I'd like to pick off of that list is the completeness of requirements. A good requirement should not leave ambiguity on the table. You should have a full scope of what you're trying to say. You need to have your figures, you need to have your labels or software responses, so that in the context of that one requirement, you're not depending on extra information in order to know what that requirement is actually trying to prove. TBD is the enemy of a complete requirement. However, if they can't be avoided, then you have a responsibility, mostly to yourself, down the road, to know why you don't have that information. Does the customer not have a specification yet? Is it something that needs to be determined empirically? And then understand, how do we get around this? When will we know this information? And then who actually is owning that process? Is it the customer? Is it you? Do we have to do some R&D work or prototype work in order to be able to clearly define that TBD? There are cases, though, and this kind of goes back to the barcode example, where maybe the format isn't specified, it's not a critical detail, or maybe it's something we expect to change several times. There is another term that we incorporate into requirements sometimes, UCF, user configurable. And that does give you a little bit of flexibility in certain instances where you're not really giving away the whole show by allowing them the opportunity to change what that requirement dictates in specificity, but you also don't have to go back and revise the requirements every time that the customer changes their mind what style barcode they want to use. A couple examples of complete requirements. So if you have a look at these reporting-related requirements, the system shall create a test record in a database for each UUT tested. The system shall record the test socket to the test record. The system shall record the test date and time to the test record. The system shall record the operator name to the test record, and the system shall record the overall test result to the test record. How do we feel about this as a complete requirement? This is a good, complete requirement. We don't have any external dependencies. There's no ambiguity. We have individual pieces of information that belong in a report and individual requirements that tie each piece of information to the system. So we know each of these 5 things need to be in a report, and they're independent, they stand alone, and they're easy to verify. You can have 5 different steps in your verification plan that says, yes, I have a test record in a database. Yes, I have the test socket, the date, time, the operator, and the overall test result. So by having these complete, isolated results, you make it very easy for yourself down the road to prove that this all happened. Next example, the system shall display everything the operator needs to know on the user interface. Yes, you're absolutely right. This is a terrible requirement because it's very ambiguous. This goes back to terminology where what is everything that the operator needs to know? And what does on the user interface mean? We don't have any guidance on what we need to put there. We don't have any guidance on how it should be displayed. Does it need to be a chart or a graph? Does it need to be an image? Does it need to be a digital readout? So something like this is where you want to see something more like the prior example, where you have, even if it takes 20 or 30 requirements, one for each bit of information that you need the operator to see. So you've made it very clear what that set of information is. And then you can, in those requirements as well, dictate this is a digital readout, this is a string readout. And again, that gives you an opportunity to make it very easy on yourself in verification to show that that's actually happening.
So I have a question. I'm actually managing a project right now. And noticing if you're trying to put all the details that you described, usually the people that need to learn, they like lays out, they cannot look at it anymore, and
Sure.
they don't know what you're talking about. So I feel that you need 2 levels of requirements. One of them should be like this, which tells them what you're actually going to do, and then for the programmer, you need the different details. Because if you're giving to marketing people the little one, they're just not going to read it.
Right. So I think we're not really looking at 2 different requirement documents there. You're maybe looking at a requirements document that has your granular detail. These are your rules. This is the law that you have to follow. And then maybe you have a design document that makes it a little more digestible what the operator interface is trying to accomplish. There is also organization of requirements that we'll touch on in a little bit that can help separate out the granularity of your requirements so that you're not bombarded with 2,000 requirements when you just care about one submodule.
Yeah, because if you're going to say this set your requirements,
That is absolutely true. There comes a point where you're looking at more like a discipline problem than an issue with your documentation. But there are strategies you can take to make it a little more easy, a little more focused, so that you don't run into that problem. Sure. The verification requirements is something that we touched on just a little bit. We're looking through this V model, and this is just a reminder to reinforce, as you're writing these, okay, we have these 8 parameters that we care about to define a good requirement, but we also really want to be thinking forward, okay, it meets all the checkboxes, but can I actually verify this? Can I, as an engineer down the road, picture a way that we're going to be able to prove that this works, and will it be easy and cost effective? So these are 2 tie-ins we have from the CPAD project. These are taken right out of the spec that we saw earlier with Becky. This is a requirement for the generation side. The generated level between 70 and 104 dB SPL at 10 centimeters at all frequencies between 100 hertz and 10 kilohertz. Is this good or bad? Do we like this or hate it? You don't like it? Why not? That's exactly right. So it is ambiguous, and it's actually 2 parts. It's dictating a distance between our instrumentation and the DUT without telling us what precision we need to accomplish that have accurate measurements according to the customer's intention. And the range of frequencies between 100 hertz and 10 kilohertz is potentially infinite because we don't have a step size. And if we look in the customer spec, we'll actually see it's not in linear increments, but they're actually sparse. So this is a place where maybe you have a requirement that dictates these are the frequencies that we'll generate on, and give yourself that opportunity to reduce your design complexity, pick an instrument that meets the actual requirements of the intention. Second one from the CPAD project, on the analysis side, the DUT requires a PDM clock frequency of 3.2 megahertz plus minus 200 ppm. Is this good or bad? You're shaking your head. Why do you think so?
The fact that your tolerance is in a different unit compared to your overall spec.
Well, actually, with frequencies, that's okay. With parts per million, that relates to frequencies just fine. But it can introduce some ambiguity to somebody who doesn't understand the relationship between frequency and parts per million. So it does depend on the intention of your specification, but you could just as well convert that to a plus minus hertz. This is actually a nice requirement because it gives us a specific frequency with a tolerance. We know the signal that we have to provide, and we know how precise we need to be on that signal. So managing requirements is just as important as figuring them out in the first place. Once you have all these, what do you do with them? We have to write them down, and this is where I was speaking to you about organization. You can break these up into different tiers of coverage. You can have requirements for individual fixtures or individual user interfaces based on the complexity of your project. That helps silo the complexity a little bit so that if you have a developer working on just one fixture or just one screen, he only has to care about those requirements and he's not hit with the rest of the noise of a larger application. So that can help reduce your individual developer or engineer's complexity by breaking these up in a reasonable way. What it does introduce is, of course, tiers, and you have to make sure then that your tiers of requirements still agree with each other. There is a difference between documenting your requirements and managing your requirements. Documenting your requirements is putting them down. So all the tools we see on the left, that's what you could use to document your requirements. That's not managing your requirements because there's a relationship between requirements and your project goals that's beyond just written text. It's very common to use unique identifiers so that you can always say, all right, this specific requirement, whether or not it's been redacted or changed, you can track it throughout the whole history of the project. And the tools on the right give you the capability to do that. They're purpose-built tools with the goal of recording requirements, tracking them through project lifecycle, allowing changes, collaboration, and then giving you a report at the end that says, here's all your requirements, this is how they change, here's how you can verify them. And verification, as we have talked about, is a critical stage here. Because requirements can and do change, it's not a bad thing that they change. But as you're changing them, you want to make sure that you're keeping your test up to date, your verification plan up to date. And we have these 5 different tools in order to verify them. There's 5 different strategies. These are baseline. You may find other strategies as well, but these give you a baseline idea of how you might be able to verify different types of requirement with different strategies. Here's an example of a test report. So you can see there's written requirements, and based on the type of the requirement that we have here, you can maybe, there's only 2 different types here, but inspection versus demonstration. So for an inspection, we're talking about communication over an RS-232 port. Well, you can attach a serial logger there and inspect and see if, yes, I'm passing RS-232 traffic, and that is working correctly. Compared to a requirement like the test software shall display an operator interface when the operator opens the test software. Well, you launch the software, and you can see the test software open, and therefore you have demonstrated that that requirement was met. So in review, there's 4 major points that I want you guys to take home. Use requirements to familiarize yourself with a project and keep scope creep in check. This is the biggest enemy of timely and cost-effective projects, is not tracking what your goals are and then allowing them to change. You want to take advantage of existing standards and your own experience, your team's experience, to be able to write quality requirements based on your ability to verify them, based on your ability to find them on your customer's information, and set yourself up for requirements that you can prove. And you do that by writing your verification plan at the same time, making sure that you keep it up to date with your requirements as they evolve, so that you don't get 2 weeks out from delivery and find out the verification plan you have proves a completely different set of requirements. And finally, there's a lot of tools that you can use in order to make this process easier. You don't have to just open a notepad and pass that around the office. There are more complicated tools and there are less complicated tools. You need to decide based on the size of your team and the size of your project where that balancing point is. But these greatly streamline and augment your ability to define requirements well and then track them to the project so that you have a successful solution. And tag team. All right. So just a quick slide. This is my contact information. If you want to learn more about, I guess I should have put this at the end, but there it is. Oh, well, I'll say that next. Here, I got a shameless plug. So I'm the admin of the NIWeek. If you've ever gone online and did a search, you might end up hitting it. So I have ribbons for the NIWeek that you can have if you want one. And then I also am the writer of the Q Control Toolkit, and she wants me to show you I got the Community Contribution Award this year for the Q Control Toolkit, and I have some ribbons for that too. So there's my shameless plugs. Now we're going to go into what you're actually here for. Okay, so you're probably wondering why the hashtag project requirements in the title. Well, that's my half of the presentation. So I'm going to talk about using bookmarks to track your requirements, but I'm going to take it one step. Most of you, how many of you are familiar with Requirements Gateway? Okay, I'm not talking about that. I wrote something else that I think is cooler, but it's not, what I'm doing is not just for requirements. So I'm going to talk about just one slide on what a bookmark is again, for those that might not know. What I think is missing from bookmarks, in my opinion. How to specialize the bookmarks, and then I'll actually get back to the requirements tracking part. So what is a bookmark again? So a bookmark basically is, well, it was introduced in NIWeek 2013, and a bookmark is that hashtag and then a tag, whatever word you want, and then whatever other text you want in there. And actually that hashtag and that tag word could be anywhere within that bookmark, anywhere within that free label. It doesn't have to be at the start. But, you know, terminology-wise, depending on who you are, if you're my mother, the tic-tac-toe sign. So anyway, what's missing from bookmarks? Bookmarks is a great thing, but I think that it's missing some things. First off, does your bookmark manager look like this? So what's missing? Let's see, it's got many variations on the tags. There might be tags that are used by your framework. Some things are misspelled. You have variations on caps, like is your to-do all caps, is your to-do all lowercase. There might be terminology difference. One programmer calls it requirements, one person calls the tag covers. Or there's VI Analyzer tags, like in NIWeek 2018, you can actually tell VI Analyzer to ignore certain tests by using a tag. And so there's just all of this stuff in the bookmark manager. So what's missing? First off, standardization. How do you standardize your bookmarks? You might have different tags with, like I said, spelling or capitalization differences. Maybe you have formatting differences. Someone really wants you to know that that's a defect. So they made it nice and big and red. Or maybe the layout's different. One person puts it there, one person puts it there. Terminology differences, and so forth. What about adding extra information? What if you need to add some extra information to describe what's going on? You know, either you have tags that are supposed to implement, you know, a link to a database or something, or long explanation, or a status like up there in process. How do you add those things and make it consistent? No, this is the right version. Okay, and also, I think another thing that's missing is a filter in the bookmark manager. How do you find stuff? Here's an example. I want to find a specific to-do. Let's see, I'm going to go down the list. Let's see, where's my to-dos? Oh, there's like 3 different ways to spell to-do on there. So let's see, maybe up a little more. Oh, there, wait, there it is. There's the to-do I'm looking for. All right.
So possible ways to fix this. You could create a team style guide, and that helps, you know, maybe it doesn't help enforce it. You can create merge VIs. That's where you put a VI into a palette, and when you drag and drop it, instead of dropping the sub VI, it drops the contents. So you could basically you could have it pre-created. You could do VI analyzer tests to catch when there's a mistake. You can create your own bookmark manager, which is something I'm going to show. You can use get and set and get tag scripting properties. I'm going to show that too. So otherwise, you can specialize your bookmarks to make standard bookmark types. So how do you specialize a bookmark? This is my first attempt to specialize a bookmark. So what this was doing is I was trying to track defects in a tool called RTC, or Rational Team Concert. It's an IBM tool. But you had to put in all of this extra information into it in order to tie into the database. It needed to know stuff like, you know, who discovered the defect, what phase was it discovered in, all of this stuff. And you can see it was huge. Covered up my block diagram. I'm like, this isn't going to work. I need something else. It was implemented through Quick Drop, where it would pop up a menu, you know, a form, and you could fill out these fields, and then it would drop it onto the block diagram. So this is when I learned about these get and set tag properties. Have you guys seen these before? Basically, you could pass the reference to your bookmark declaration into that. And then in the tag name, you can set that to whatever you want. You know, make it something pretty long and specific so you're not overwriting someone else's tag. And then in the value, that's a variant. You can put anything in there you want, even class objects. And so what I ended up doing is I ended up creating specialized bookmarks that you can inherit from a bookmark object. You can specialize that to be a certain type of bookmark. And then you can save that data in here. And then when you read the data, you can read the data out and figure out what type of bookmark that is. And then through Quick Drop and right-click menus, I have a bookmark editor. And I'll show you that in just a minute. That lets you basically plug in what type of bookmark it is, what kind of information you want the developer to fill out. And then it saves most of that data under the hood. You can decide what formatting you want, what data you want displayed, and how the colors and everything, the formatting, the spelling, everything is standardized. So here's an example. I'm going to create a bookmark by doing Quick Drop and calling the bookmark editor. I'm going to say I want to create a to-do. So I'm going to say show specialized bookmarks at NIWeek 2019. And then I'm going to put in a description, hello world. And I could mark it complete. It's not complete yet. Haven't finished showing it. Okay, there's my bookmark. My to-do bookmarks I made green just because that's what I chose to do. Now I brought up the bookmark editor again and marked it complete. But then I also made it so that you could access that same stuff through the right-click menu. So I could come in here and open it up again, change stuff, maybe mark it not complete, or I could do it right in the right-click menu and mark it complete. So now, the next step is, okay, let's customize the actual bookmark manager. Let's have the bookmark manager be smarter. Let's have it provide filtered views based on these now specialized bookmarks, and be able to access and view that underlying data in like a table format. So here's my specialized bookmark. I go access the bookmark manager. You can see if you have more than one, you can select, and you can put do not show again if you want to select a standard one, and then it won't show that pop-up anymore. So here's my bookmark manager. You can see the standard one, all bookmarks, is just like the old one. But then I'm going to say I want to view just my to-dos. So here's my to-do bookmark. I can open the bookmark editor from here and change stuff. I can also highlight it so I can go find it, just like before. I can also actually change the status of it with a click right there. And then, I also, if you have a whole bunch of to-dos that you want to get rid of, you can say, delete all of my to-dos at once. Delete all of the ones that are completed. Just get them out of there so that they're just temporary. So now, back to requirements. Wait, this was a lesson on requirements. Why are we talking about to-do bookmarks? Well, I created a special requirements bookmark. So I made it so that it interfaced with the database. I had fields connected to that database that are automatically pre-filled. And then I had custom formatting for a requirement bookmark with special formatting for the status so that you could easily see the status. So now I'm gonna do this a little different. I'm gonna create the bookmark just like you do before. Just type in requirement. And then I come in here and right click, say I'm gonna convert this to a specialized bookmark. So the editor pops up. I'm gonna change it to a requirement bookmark. And then these are from my database. So I pick which project it is, I pick which requirement ID, shows the title and the description from the database. I can come in here and put in my own specialized notes for this requirement. And then click OK. So there's my requirement bookmark. Coming back into the bookmark editor, change the status. I can also change the status right from the right-click menu. So all of these things are things that you can build yourself, and they're all available through the right-click. You can already override and build your own bookmark manager and all of this stuff. This all ships with it. So now for the requirements view of my bookmark manager. It's going to allow me to change the status and all of that stuff as you saw before, but it's also going to give me a dashboard so that I can see the overall status of my project. So here's my bookmark manager. I'm going to go into the view for requirements now. So here's all my requirements in my project.
All your requirements there, are those pre-populated? Do you load them in, or have you manually created those as you're going?
These I created as I went.
Okay.
Well, for this particular thing, I scripted up to make it do this for just as an example, but the idea was you'd make them as you go.
Okay.
I have also, so this is part, although your requirements are part of the code, so if you change a requirement without you change the code, that's making the code change it without linking into the source code?
Yeah, this is a way to track the requirement that you've covered it in the source code.
But if it's part of the source code, you change the requirement, but you didn't change the code.
Well, if you change the requirement, then you would want to go change the code, because the requirement might lead to a code change. If a requirement changed, then I would expect that some code has changed, or should change, as part of that. Otherwise, why did the requirement change? Well, if it's just an explanation, then that requirement tag, like let's say they just updated the explanation in the database in your requirements tracking tool, and they updated maybe some wording, but it doesn't require a code change. Well, because what's saved with the bookmark is just the tag, not the rest of the text, when you bring it up again, it's going to go re-query the database and bring up the corrected text.
And that in turn, it's a bookmark in the PI, that PI, like he's saying, is now going to flag by the source control as having changed.
No, not unless you change something specifically in the bookmark. But then nothing specifically changed. You're saying nothing needed to be edited in the code.
Maybe I misunderstood. If Tony says that somebody changes the description in the database,
Mm-hmm.
in turn causes it.
No, it wouldn't force it to change until you went to look at it. Let's say you went back into that code, and then you brought up the editor, and the editor went and queried the database and brought in the description that matched that ID tag. So it's really only the ID tag that's being saved with it. So Does that make sense? Okay. Yep.
So since you're implementing this for you, that's how you get to it. If you wanted to have a way of flagging it, it's one way you just have a finger change status.
Yeah, this is an example. You can definitely implement this the way that you need to. You know, program your own type of requirement. Yep.
Can you physically connect with RTC? Have you done?
I have not
Okay.
done it, but it is possible because we do have tools that are built by so where I work at Hill Air Force Base in Ogden, Utah, and our RTC team has built tools, but they haven't given me access to have the API. Oh, sorry. The question was, have I directly connected to RTC myself?
Is there a way, so you have this whole list of requirements tracked now.
Mhm.
I see you have a view summary. Is there a way to generate a report or something so that you can share that with people?
Definitely. That's not something that I have implemented yet, but that's something that you could implement in here. You could put in another button that says print report. You could put in some other things to help you filter, some sorting, or maybe a text search. These are all things that I've had in mind to implement, but haven't implemented yet. So, okay, let's see. If I can just click on this again and have it. So what I'm showing is that I actually double-clicked here and was able to change the status. And then clicking on View Summary, this is actually a queue control. So, but it's a pie chart that's showing me my coverage. So I'm going to close that now. I'm going to go change the status from blocked back to completed. You can see it changed to completed up there, and you can see that the summary has changed as well. So like I said, this is how I implemented it. This is a plug-in architecture. You could go program your own type requirement, and actually that's the next step, because you would have to know the API for your specific, requirements tracking database. If you use DOORS, if you use RTC, or I guess RM is the requirements part of that, or anything else. You also need to decide, what do you want to display? How do you want it formatted? What things do you want in the bookmark editor that maybe isn't displayed in the actual bookmark? And what kind of functionality do you want the bookmark manager to have? As part of this plugin architecture, there is a bookmark view class that you can override and say, okay, this bookmark view class is going to look like this, and then that gets put into a subpanel into the actual bookmark manager. And eventually, you could program this stuff on your own. The get and set's really where the power is, the get and set tag. That's where you're saving all of that extra data. But I will be putting this on the tools network eventually. So hopefully not too much time, but I don't know. So anyway, that's all I've got. But is there questions for me or for Chris?
Let's just say you're developing a computer that has your toolkit installed, and you move to another computer that does not have the toolkit on it. Are we going to see any odd behaviors or any issues with some of that stuff?
You know what? Probably. That's not something that I've worked out how to handle yet. Because it's going to try to read that. Well, let me think.
Bookmarks stand by themselves.
The bookmark will be by itself. That's true. The right-click options would go away. You wouldn't access the actual tag, so I don't think you'd have any crashy behavior or anything like that. If they edited it by just double-clicking on it and starting to type text, well, in my bookmark editor, it will catch that and say, wait a second, the text that's displayed doesn't match the data that's under the hood. So it will warn you. But if you didn't have the toolkit installed and someone edited it, would edit just like a regular bookmark would. It'd just be out of sync with the data that's saved under the hood. So, yeah, you're right. It wouldn't actually cause any bad behavior as far as crashing or anything like that. You just wouldn't be able to access that data.
So, real quick, you said saving the data under the hood. Where exactly are you storing the data?
So that data, when it's stored as a tag, actually gets saved with the VI that the decoration is in, that the bookmark is in.
I didn't completely understand. What is the motivation of the requirement as part of the VI?
So in some cases, some projects have deemed that in order to make sure that they've covered all of the requirements in the code, that they go put a tag in for that requirement, saying that it's been covered here at this spot in the code, on this VI, or VIs, if it's on multiple VIs. And this is actually something they teach as part of the CLD test and the CLA test, is to go put requirement tags in the code so that you can prove that you've covered the requirements. And so, you know the V diagram, the bottom of the V is the development. Well, if you need to tie that back up to the requirements, this would be how to do it, to make sure that you've covered everything.
And other tools like Requirements Gateway kind of does the same thing, except it scans your LabVIEW code looking for particular things that you define. That's why you're in Requirements Gateway. It's just another way to implement it, but it's native LabVIEW, you don't have to leave LabVIEw.
Yeah. So what Becky said is Requirements Gateway can do this same kind of thing, but it scans all of your code for any free labels, trying to decipher if that's a requirement tag. This is a way to do it with just native LabVIEW. You don't need the extra tool. Right. Any other questions?
You're connected to a database where you are already finding the requirements that mean that you like another program like Jira, for example?
As long as you know the API for Jira, then yeah, you could. So the question was, can you interface with like Jira instead of, you know, like a database? Well, I would assume Jira under the hood is some sort of database as well. And I know there's API for it. I just don't know, I'm not familiar with it enough to say, so.
There's a presentation later this week on Jira integration in LabVIEW by Chris Roba, and so if you look in the app, you'll be able to find that one tomorrow.
Yeah. So a lot of this is kind of up in the air. All I did was an access database. I did something really simple just as a proof of concept to show that, hey, this is something that you guys could go do too. Any other questions? All right. Yeah. Feel free to come up and get one of my ribbons if you want one.